Are you there? Welcome back to Think Tank Online Learning. In this video, we're going to look on Fourier transforms. Okay, so Fourier transforms are very important. We're going to need them, especially in solving PDE and differential equations. Okay, so now, what is the formula for calculating or for finding the Fourier transform? Okay, so just like in Laplace used to write an L here. So here we're going to write f, which is going to represent the Fourier transform. After that, this is f of x, which is the function, and we're going to integrate that function, okay, with respect to t. That means we're going to change the variable from x to t, and we're going to integrate it from negative infinity to positive infinity. And you should note it's not from negative L to a positive or just number. We're going to follow this from negative infinity to positive infinity. After that, we're going to add the exponential to the power I, and this is I for complex because our transforms are going to be in complex, and this is omega t, and we're going to integrate with respect to t. But if you want, you can change. You can write x here and you can write x here. That means we're going to say dx. Okay, so our question is find the Fourier transform of gx, and gx is a composite function. Okay, so this is a step side function, this is a step up function. Okay, so now what we're going to do, it's very simple. We're just going to write our formula. We're going to write the Fourier transform, and I'm going to represent the Fourier transform by the capital letter F, and I'm going to say g of x is going to be, we're going to integrate g of x from negative infinity to positive infinity, and after that we're going to add e to the power negative I lambda, okay, lambda t, but I'm going to put x since I'm choosing x to be my variable, and I'm going to say dx right here. Okay, but I have said we're going to integrate it from negative infinity to positive infinity. Okay, so let's look at our limit. What does that mean? What does this mean? Okay, so the absolute of x greater than k, this means from negative k to positive k. Okay, I know you're familiar with this one. We've been using this in mathematics. Okay, what about this? Okay, so this means from k to infinity. Okay, so this means from k to infinity, this one. Okay, but look at our formula. We have negative infinity, but we don't have any negative infinity as part of our step up functions. So what we're going to do, okay, we can add that. Remember, this is the lower bound, which is also the upper bound of the previous function. So what we're going to put 0 here, and what is going to be our 0? So our 0 is going to range from negative infinity up to this point, and this point is we're going to call it negative k. Okay, like this. As you can see, we didn't change anything, just the appearance, but the value is still the same. Okay, so now let's go on to find Laplace transform. So I'm going to start with this one. So I'm going to say from negative infinity to negative k. Okay, and what is going to be my f of x? In this case, g of x is going to be 0 times e to the power negative I omega x dx. Okay, plus we're going to add all the step out functions. Okay, so we're going to now moving on to 1 over 2k. So it's going to be it's now from negative k to positive k, and we have 1 over 2k for f of x, f of t, and e to the power negative I omega x dx. Okay, now we want 0. Okay, we have to include 0, and 0 ranges from, we said 0 ranges from k to infinity, and we're going to say 0 times e to the power negative I omega x dx, like this one. Okay, as you can see, we've said the range of our integral is going to be from negative infinity to positive infinity, right? Like this one, negative infinity to positive infinity. Okay, so now I want to integrate. Okay, so there are many methods to evaluate this one, but the one I'm going to show you is the easiest. Okay, so now let's go. Here I'm going to get 0. This is 0. and you're going to get 0. So only concerned with the middle integral. Okay, so what I'm going to do, I'm integrating respect to x, so that means 1 over 2k, or k is just going to be a constant. So I'm going to write 1 over 2k here, and I'm going to say it's from negative k to positive k, and you're going to have e to the power I omega x dx. So if you want, let's say you don't want to play with these types of limits from negative k to k, you can just change. You're going to multiply here by 2, and after doing that, you're going to say from 0 to k. You can do that, but for the meantime, I'm not going to do that. It may cause confusion to you, so let's just continue with this one. Okay, so now we're integrating exponential. So what we're going to do, just going to divide it by its derivative. So what do we have? You have 1 over 2k. 2k is not affected, it's a constant, and we're going to have, what about here? It's going to be negative I omega x. What is the derivative of the power with respect to x? So the derivative of the power with respect to x is going to be negative I omega. This is I, not 1, okay? And we're going to put our limits. So our limits is from negative k to positive k. Okay, like always, upper bound minus lower bound. Let's do that. 1 over 2k. We're going to have e to the power negative omega k. Okay, so this is I omega k minus, okay, let me just divide this by negative I omega. Now I'm going to say minus the lower bound is going to be e to the power negative I omega negative k divided by negative I omega mother brackets. Okay, now let's continue. Okay, so I think you can see negative and negative is going to give you positive, and here we have negative and negative are going to get positive. So I'm going to say 1 over 2k, and I'm going to have e to the power negative I omega k divided by negative I omega, and I said this one is going to be plus e to the power I omega k divided by I omega. Okay, and let's close our brackets. Okay, so now what we're going to do, I omega is just a constant, so let's pull it out. Okay, so I'm going to write here, I'm going to factor out negative, right? It's going to be negative 1 over 2k. Okay, so this one is going to become a positive, right? If I factor out negative right here, so what is going to happen? We're going to have, okay, I think, but I can factor out negative I to negative I omega. I think that is the best solution. Negative I omega, okay, like this one. So what I'm going to left here, I'm going to left with e to the power I omega k, and right here, since I factored negative, now I'm going to have minus e to the power I omega k, like this one. Okay, so at this stage something looks interesting. Okay, you should remember that in complex numbers, we are all familiar with complex numbers. Okay, so in complex numbers, what is the identity for sine x? So this is, we're going to have n over 2i. Okay, what about on top? What are you going to have? Okay, so remember, this is the negative. If I split out this negative, you're going to see this is going to become a positive, right? Okay, before I do that, let me just write it here to clarify what I'm going to do. 1 over 2k iw, and I'm going to have e to the power I w, which is omega k, minus e to the power negative I omega k. Okay, so we say the identity for sine x in complex variables is going to be e to the power I x minus e to the power negative I x over 2I. And you should remember this is going to be very helpful, especially in Laplace, in Fourier transforms. Okay, so this is the short method which I'm going to show you, and it's also the most recommended method which I'm going to show you. Okay, which I'm showing you. Okay, so now this is same as saying, do we have 2? Yes, we have 2. This is our 2. Do we have I? Okay. I'm sorry, I've written pictorial way. It's supposed to be I. Okay, I'm sorry for that. This is I. Okay, do we have I? And I is right here. Okay, so that means since this one is at the denominator, it's same as saying 1 over k w, like this one, and we're going to have e to the power I kw minus e to the power negative I kw over 2I. Okay, now we're good. We can write this as 1 over kw, and we're going to write sine x. Okay, so this is x, and right here x is going to be kw, like this one. So this is going to be our final answer. Thank you for watching, guys. I hope you subscribe. That's how you can support us by subscribing.